Hello everybody, today we're going to be taking a look at this dynamic programming type of problem. Well, it's not a dynamic programming problem, but we're going to be solving this problem using dynamic programming. So first, let's get an idea of what the question is asking for. Given two strings s1 and s2, find the length and optionally the substring itself of the longest substring that is common to both strings. The substring must be contiguous. So what this means is, for example, let's say we have a string length of s1 being a, b, c, d, e, and we have string 2 with the length called a, b, f, c, e. So let's say we have those two strings. What we want to find is the longest substring between those two strings. And so for example, A, B, C, D, E, it can't be A, B, C because A, B, C isn't in the list. It can't be C, D, E because there's not in the list. However, we see that both A, B is both in S1 and S2. Both of these strings have the section AB in there. Therefore, the longest common substring between those two strings is going to be AB. So the output would be AB. I'll just comment this all out. So that's kind of how this problem looks like. So let's go about the problem solving method. What we're going to be doing, let's define the function first. Longest common substring. And then we got S1, S2. So we got two substrings here, right? To start off with, we'll start by just creating two variables for the length of the substrings, because we're just going to be looping through these things in a specific type of way that we'll get to in a bit. So we'll have two variables m and n for the length of the substrings. Now let's get our, what do we call it, the tabulation array, the DP table. So we're going to get DP, and then this one, it's going to be a matrix. So the matrix is going to be using the lengths of the two strings. So we're going to do 0 times n plus 1, and we'll get to why it's n plus 1 in the second, for x in range of m plus 1. So what this code is essentially doing is we're creating our dynamic programming table, and what this is going to be is it's going to be a matrix of the number of characters in the string plus 1 squared, basically. So for example, in this string A, B, C, D, E, there's 5 characters in the string, so the length is going to be 5 and then 5. So we're going to be, what this string would look like is it's going to look something like zero, 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 0, because there's 5 plus 1, so that's 6 of these. And then it's going to be a matrix of this 6 times. 1, 2, 3, 4, 5, 6. And then all of this is going to be in a list. So that's just a better visualization of how the specific matrix would look like. It would look something like this. That's what we're creating here, essentially. Now, what we're going to be doing is we're going to be looping through the list, starting from not the 0, because the 0th element would be this first element, but we're not going to be using that. we're going to be using starting from 1 comma m plus 1 shoot, and then we're going to do the same thing for j in range of 1 comma n plus 1. So this is going to be looping through the rows, each individual column in what do you call it? It's going to be looping through each individual row, and then in each row it's going to be looping through each individual column, starting from the first value and then going up until n plus 1. And we're going to see why we're going to be doing that in a second, because essentially what we're going to be doing is we're going to be indexing into the string of I minus 1. So what this is doing is it's taking the string, so for example this value here, and if the value is 1, which is going to be the second value, it's going to be comparing this to no, it's going to be taking the first value since it's starting at 1. It's going to be taking the first value and comparing it to this value is equal to s2 of j minus 1. Then we're going to be putting the value into the matrix. dp of I j is equal to not equal to. We're going to be setting it equal to the previous value in the array. I minus 1, j minus 1, plus 1. So what we're going to be doing is we're checking each individual value to each other, because we want to see that, oh, the first characters are the same, and if that's the case, we're going to be adding them to our dynamic programming table right here so that we can store it in memory and then come back to it later. So now we're going to have, I forgot to mention here, we need to have two variables here to track continuously. So max length, which is going to be the maximum possible length of the substring, and we're going to have n position. We're going to set these both to 0 to start off with. Now we have this thing. This is the first condition that we need to check, and we also need to check that dp of I and j is greater than max underscore length. Because if it's under the max length of the string, if the value that we have in the table is just not is the same as the thing, like for example it starts off at 0, if it's not greater than, then there's no point in adding it to the max length list. But since it is, if it is, we're going to set max length to be that value that we just set into the table. And then we're going to increment the n position by 1 by setting it to I. So we got all of this, else we're just going to simply set the value to 0, because it means that it didn't meet the previous conditions, that we that the values weren't the same, and it's not worth going into checking to see a valid long substring. So we're just going to be setting that to 0. And yeah, that's basically how all this code works. In the end, we can just test it real quick just to see if it's working. Longest underscore comment substring. is equal to S1 of the last position of the string minus the length of the string going towards the end position. So for example, if the end position, for example, in this case, when we calculate the thing, the end position is going to be the second element, because the second element, 1, is where essentially we're done. So we get to the second value in this matrix, 1. So we get to that end position in both of these strings, and we're going to be checking S1 going up until max length, which in the case of this problem, the max length would be 2, but we're going to go to 2 minus 2 minus the 0 to 2, which would result in this going up until the, sorry, not 2, I mean 1. End position is here is going to 1, right? So it's going to be the max length, which is going to be 2 characters wide. So it's going from 1 and then it's going to 2, because the code actually starts at 0, but going to 1, and then it's actually going to end at 2. Sorry. By the end position, I don't actually mean the index of the second value. It is going to be the end of this first index here. So it's going to be 2, and that's how we get this entire calculation of finding the longest common substring. Sorry about the botched explanation, but hopefully you kind of see what I mean. We can then just essentially return the longest substring. Okay, now let's test our code. If we say print longest common substring of let's set them here real quick. S1 comma S2. If we did everything right here, we should get the values AB. So as you can see here, AB is the longest common substring between those two values. We can take a look at some of this other thing, some other edge cases. So for example, if they're the exact same string, we can make sure that the value is the same. Okay, the value is the same. S1 is and S2 are the same. So the longest common substring is the whole thing. We can take a look at this this one. As you can see, the substring is expected substring is 1, 2, 3, 4, 5, because 1, 2, 3, 4, 5 are in both of these cases. Run the code, and yes, as we see there, it's going to be 1, 2, 3, 4, 5. So yeah, that's basically how this problem works. Hopefully you kind of got through the step-by-step solution of how we came to this solution using dynamic programming. It is the most efficient solution, and yeah, hope you guys enjoyed it and learned something. Alright, see ya.